My guest for this episode is Jack Gilbert, a professor of paediatrics and oceanography at the University of California, and one of the authors of Dirt is Good, the advantage of germs for your child's developing immune system. We're going to discuss germs, COVID-19, mucky play, and why the right dirt at the right time could be good for kids. Jack, hello.
Hi, how's it going?
Good, good. So when we say dirt, what do we actually mean by dirt? Are we talking mud? Are we talking bacteria?
Yeah, dirt is an odd term, right? It's very colloquial. It can mean many different things. In the context of this, it just means the stuff that people would normally try and protect you from, right? The bacteria, soil, mud, but also general filth out there in the world, right? And there's filth that's going to make you sick, and there's filth that can make you healthy, and that nuance, division between the two is where we find the biggest rub, the most difficult thing to explain to people, and the most education that could be required.
Yeah, because when people think of dirt, it's rare that they think this might be good for me, other than in a psychological sense, perhaps. Rolling around in mud can be fun, I guess. But in terms of good for our body, what does that actually mean? Is it something around the myth? Or you spoke to one of our journalists, John Morgan, about this myth that we need to expose ourselves to as much dirt as possible to stop allergies. Is that true?
Yeah, to a certain extent. I mean, it all comes down to your immune system, right? How your immune system functions. Most people think of your immune system as like an army, right? It's an army to defend your body against pathogens and germs. And that's the rhetoric that we've been fed over the last 100 years since we really started to understand what it does. But really, the immune system is more like a caretaker or a national park ranger or a gardener. It's there to manage the microbial exposure and the exposure to everything else that the human body gets on a day-to-day basis. Each of us is emitting around 38 million bacterial cells an hour, right?
Okay.
And we're also receiving lots of microbial and pollen and dirt antigens from the air, from the surfaces around us that are being sensed by the immune system in our skin, in our lungs, etc. And the immune system has to deal with all that, right? It has to manage that complexity of exposure. And that's where it all becomes complicated. If your immune system doesn't see lots of things, right, it can become lazy, to use vernacular, right? Yeah. And a lazy immune system is one that can overreact when it finally starts to see antigens, things that will activate the immune system. So what we found is that if your immune system sees a lot of things, a lot of bacteria, viruses, dirt, pollen, etc., very early in life, within the first 18 months, it can train it to be active and healthy so that it doesn't overreact when it finally sees something which it is not expecting, right? So it's very much, there's a nuance there, but it's it's quite difficult to explain without going into the biomechanics of immune cells. But it's the paradigm is, exposure to lots of things very early in life can help to train the immune system to be less overreactive.
And are we talking small doses here? I mean, we're not talking chucking one of our children in a muddy pit and letting them eat what they want while in that muddy pit, and there may have been foxes, badgers, rats, who knows in there. I mean, is everything in moderation?
Everything's always in moderation, right? But if you expect there to have been a large uranium dump, I wouldn't go and throw your children into the uranium dump, right? Or a chemical wasteland. You have to use common sense, which is often complicated to adhere to. But the paradigm is bring your kids out into the garden and let them garden alongside you, or go out into a park. Go for a picnic or a walk in a forest, or have furry pets around. Exposure to dogs under the age of 1, not the dogs being under the age of 1, your kids being under the age of 1, will reduce the chance that the child will develop an allergy like asthma by up to 20%. Right, that's a significant reduction in the potential for a chronic allergic disease, just by physically interacting with the dog. There's a nice paradigm there. We did another study in Philadelphia, in a poorer, socioeconomically depressed part of Philadelphia, and we saw that there were lots of kids with dogs that were still developing asthma. And we thought, well, this is odd. This doesn't fit the paradigm. Until we found out most of the dogs were guard dogs, very aggressive animals that were kept outside on chains in kennels. And the kids weren't allowed to physically interact with them as they didn't have that bond. So we've identified that the babies need to physically interact with the dog to get the benefit of the exposure, the immune exposure that a furry pet can provide.
How crazy. So is the immune system largely set by 18 months then? I mean, should we keep exposing, when the kids reach school and this sort of the age Tes starts dealing with 4 and 5 year olds in early years? I mean, should we be less concerned with getting them in those situations where they can be exposed at that age then?
This is where it becomes complicated, right? Most of our research is focused on that early life exposure because that's the time when your immune system is being primed, right? It's being activated and educated at a very rapid rate. So yeah, by 18 months, it's feasible, and a lot of data seems to suggest that the immune system is starting to become more mature, right? But there's still growth. And remember, the immune system is actual physical cells, cells that live inside your body, white blood cells, etc., that live inside your body and are actively dying and being born and replicating. And so it's a growing ecosystem. It's an immune system that's just a living being, as you will. Alive, but it's a living, growing thing. So yeah, we think that constant exposure is beneficial, but the evidence to support that is still lacking, right? We can't definitively say it. All we can say is that we have evidence to suggest that constant exposure throughout life may provide benefit, but it's difficult to prove it. To prove that kind of hypothesis, we'd need trials of millions of people costing billions of dollars, and human beings are just not that good at adhering to regulation. So if we said, you don't expose yourself to anything, and you guys over there expose yourselves, sit in the garden and expose yourselves to everything, that would be a virtually impossible trial to do. So it's going to be very hard to prove it. But some of the evidence in animals, mice and rats and what have you, that suggests that yes, some exposure throughout the life of the animal can be beneficial. This is why we suggest people should garden, right? If they have a garden or a box on their windowsill, that they can grow plants and they can physically interact with the soil. That could be beneficial, especially later in life. So farms at schools, or getting the kids to learn how to grow their own food, could be a hugely beneficial experience, both psychologically, but maybe also biologically.
And if we flip that around and say, kids, sitting at a desk for, 6 hours of the day with reducing break times, for example, let's say they get 30 minutes for lunch and stood in the canteen, and with the COVID regulations coming in, it's likely that children will be sat in the same room, even at secondary school, for those 6 hours. If we flip that around and look at the potential impact in terms of dirt, as an overview, is that a dangerous, or is that a less than ideal situation from a microbial point of view, if you want to put it like that?
Yeah, I mean, maybe this is where it becomes even more complicated, right? So we're dealing with the same thing here in California, much worse than you are, I believe. But our main problem is that being locked inside presents a number of threats to health, right? There's obviously benefits. It's often more comfortable than the outside, other than in Southern California, where it's always beautiful. So it's more, temperature is easier, the humidity is better, it's you're less likely to be rained on, but the being trapped inside, being locked inside, presents health threats. So for example, it concentrates bacteria and viruses in the air and on surfaces from the people who are in there. So in this position of a pandemic, this is the reason the advice is, if you're going to interact with people, wear masks, stay socially distanced, but do it outside. Because it reduces the probability of the transmission of a bug. If you're inside, the bugs and the viruses get concentrated in the air and the surfaces, increasing your risk of transmission. Secondly, there's chemicals that are off-gassing off of the furniture and and electronic equipment and off of the materials used to build the structure, the school, that can build up in the air. And if there's not proper ventilation, either through windows or through bringing outdoor air in via the air conditioning system, then those can build up and they can have toxic effects. And thirdly, there could be, especially in old buildings like we find in Britain, there could be fungi, molds, living in the building structure that are producing what we call volatile organic compounds. These are chemicals which get into the air and can be breathed in and can make us sick and present allergies or cold or flu-like symptoms. So, there's lots of complications to keeping people trapped inside, both psychological and biological. So the benefit of being outside, microbiologically speaking, may be mild, right? But the problem of being locked inside, microbiologically and chemically, may be worse, right? So balancing those two, balancing that equation and making sure people get enough exposure to the outside while also making sure the inside doesn't become a chemical and biological concentrated mass, is the really difficult piece of bringing kids back into school during a pandemic.
Yeah, and in terms of the impact of, if we move away from COVID briefly, we're going to come back to it. But if we look at the off-gassing you were talking about, the volatile compounds potentially, they may have long-term impacts in terms of illnesses or viruses, and they may have some health detriments or allergies. Are there any short-term things that can happen in that class that impact the learning at that moment, or if you're in that room for the entire day, are there things that an imbalance that can happen?
There's some suggestion of this, and the evidence for it again is weak, but that's just because the studies haven't been done properly, right, or haven't been done at all.
Yeah.
But there is some suggestion that your immune exposure influences your attention, your ability to learn, your focus. It can also potentially influence anxiety and depression-like symptoms, which can also exacerbate attention deficit and various other conditions. Okay. And so under that circumstance, a properly functioning immune system that's getting the right kind of exposure and being exposed to lots of things outside may improve a child's ability to learn, may reduce their anxiety and depression levels, and potentially could have big impacts upon their ability to function in a school environment. It's telling, I think very telling at the moment, that during the pandemic, with the closure of schools, we've actually seen a significant reduction in childhood anxiety levels compared to when children were in schools prior to the pandemic. Now, you could say, well, they weren't having exams, and they weren't being in a school environment, and yes, all of those psychological manifestations are probably responsible. But there could also be a nuanced part of that, which is affected by the fact that children are probably spending more time in backyards, probably spending less time trapped in. Trapped is a very emotive word. Locked into an indoor environment where they have limited exposure during the day to the outside environment. So there's a component of that which we should consider. Now, of course, we need to do the experimental tests to understand it, but if we do, it'll be really interesting to see how much that contributes to that learning deficit that we see in some children.
Yeah, and I'm curious as to the sort of the mix, I guess. How much of what you're talking about is airborne and things we breathe in, not just COVID again, but in general, and how much is it from touching? Any early years classroom, kids touch each other, there's saliva everywhere, there's snot everywhere. How much? What are we talking about here in terms of ratios, I guess?
That's a really complicated question, but you have to understand the lung is an immune organ, just like the skin. The skin is another immune organ. People think of it as a barrier, but it has loads of immune cells inside it that are sensing the environment that we touch, that we physically interact with. We actually think that what you physically touch, and therefore what your immune system on your skin is exposed to, can affect how our organs inside work. Everything from our intestine to our kidneys to our heart. So there's the whole system is connected. So that's a fascinating thing. I would say obviously, when COVID withstanding, anything you breathe in, it's a thick mucus layer of along the respiratory tract, which is trapping things, but also in expelling them, but also allowing for a nice, warm, moist environment for things to grow. So viruses and bacteria love to try and get into that environment, and things like Staphylococcus aureus or Pseudomonas aeruginosa will find a lovely way into the body and into the lung through breathing in. But of course, anything you physically interact with on your skin is going to be shaping how your body functions. And so the transmission of disease via your skin is the most likely way you're going to pick up something, unless you are closely interacting with other children in a school environment, which of course happens. So hopefully we all now understand that you have an aura around you, and if you sneeze, the aura is expressed further of viruses and bacteria, and so if you are close to people, you are breathing their aura in, and they are breathing your aura in, your microbial aura, and that can lead to infection and disease. So it's complicated, but that's the basic paradigm.
And is that, it sounds alien and slightly dystopian, these auras around us, and it sounds quite scary, but I'm guessing if you're two healthy adults, there's nothing particularly dangerous about that, breathing in each other's aura.
In fact, it may be beneficial, right? Two healthy children sitting next to each other, their immune systems are being, to a certain extent, educated by the other person's microbial exposure, right? So the bacteria and viruses and fungi that person is emitting, remember, we each emit around 38 million bacterial particles, bacterial cells every hour, right? So there's a lot of exposure potential. That exposure could be training that child's immune system, especially, maybe under 5 years old. So in that preschool environment, in what we would have kindergarten here, the child's immune system could be being shaped by sitting next to another child and being educated by the exposure to that foreign microbial environment. And so, there's a component of that we should consider as potentially beneficial.
And if we move into COVID-19 coronavirus, and the advice is wash your hands, keep 2 meters, and make sure you clean stuff you touch, essentially. And in schools, that has been interpreted in this. Well, it's not been interpreted. They've been advised, I guess. And we shouldn't. Schools are just doing what they've been told to do in this country, at least, is to Dettol the world. That school has never been as bleached as it's ever going to be. Is as far as you're aware, what are the risks around surface transmission, and how effective is the sort of bleaching of the environment going to affect that?
Whenever we talk about advice, you have to understand that this is an emerging field, or the research is very much in its infancy. Any research that's less than 6 months old should always be considered very early and open to revision as we find more evidence to overturn our previous evidence. So in the context of this, the vast majority of transmission is airborne, in terms of what we've experienced from case studies of events where people have got sick in an environment. So your biggest risk is breathing in somebody else's contaminated air or droplets. And then also, obviously, if you do get virus on your hands, touching your nose or your mouth, right? Now, we call the environment around us, the surfaces, your tabletops, your door handles, etc., fomites. A fomite is just a surface which allows a pathogen to be transmitted between two people, right? So that if somebody who has had a lot of virus on their hand, like they had SARS-CoV-2 infection, COVID-19, and they sneezed, they had mucus on their hand, and they touched a door handle, and then somebody came along and touched that door handle and then touched their nose, it is possible that they could be infected. We haven't seen a lot, or haven't found a lot of evidence of those forms of transmission, but it doesn't mean they don't exist. But is it necessary to sterilize the entire environment? We hear a lot of reports at the moment of deep cleaning a school, right? Because some of the children got sick. They send all the kids home, and then they deep clean the whole school to try and eradicate the SARS-CoV-2 infection. Well, that's not where the kids got sick from. The kids got sick from interacting with each other and likely breathing in each other's contaminated air. And so you can deep clean the school all you want, but as soon as you bring the children back into that environment, you're going to risk transmission of the virus, not from the school surfaces, but from the interaction between the children. That's your biggest threat, right? And so this deep cleaning angle doesn't make a lot of sense and is rather problematic. It's stagecraft to a certain extent. You know, you talk about security theatre in an airport, right? You know, most of the security protocols don't really do anything to keep us safe, but it makes us feel safe because we see things happening. It's the same with a lot of the sterilization protocols. But in the absence of absolute evidence, it's probably, it's belt and braces, right? You know, we are just being doubly safe, so I can't fault them for doing it, even if there's no necessary evidence to support it or deny it. So it's you know, why not?
And I guess if those kids are, you know, well, we said it doesn't really matter before 18, but if we take it as read that a continual exposure to stuff does help as you go through life, I guess if they're having a normal experience outside of that school, cleaning that school down to within an inch of its life isn't going to have that much detrimental impact on that process.
No, I doubt it. I mean, let's say the kids are in there 8 hours a day. There's still another 8 hours in the day when they could be outside and they could be experiencing it. So this period of 6 months of a child's life, or maybe more, this period of 6 months of a child life, or maybe more, where they're exposed to a very sterile school environment, is probably not likely to significantly impact their immune system development. You know, if we were talking about an 18-month, you know, as a 6-month-old child, and that maybe they'd just been born and they're going to 6 months, and we kept them locked inside a room that we kept very, very sterile, then that could have a serious negative impact upon their immune system's development. But, you know, a 7, 8, 9-year-old kid in a school is probably not going to be badly affected by this sterilization theatre that's going on.
And away from sort of coronavirus, and there is only one story in town, but teachers say that, you know, they have this period of illness where they will be with these kids or you know, for weeks and weeks at a time, and then they have their half term and they suddenly get sick. And there's a lot of theories about why that happens, but there's these sort of contrasting theories that they're really strong immune systems, they're around children all the time and they're around all these bugs all the time, but then they suddenly get sick because they're so knackered that they just let it in at the half term or the Christmas break. I mean, is there any truth in that? You know, what possible explanation? You know, are teachers some sort of super immune beings because of the germs they're exposed to? I mean, how does it all work?
Yeah, as you astutely point out, we don't really understand what's going on there. We see this similar thing with sewage plant workers, you know, sewage treatment plants. The workers there tend to have very, very low rates of infectious disease generally, and then when they take a break or they retire, they often get a lot sicker, and we don't really understand why. We think that the constant exposure to things keeps the immune system very alert, right? It's and when it's very alert, every time an immune cell sees an organism it wants to get rid of, like a bacteria or a virus, it will engulf it and then die, right? And then by the process of it dying causes the body to make new ones. So you're getting this constant refreshing of your immune system when you're exposed to lots of things. When you don't see a lot of things, a sudden cessation in that, those immune cells hang around in the body a lot longer and they get older and they become more reactive. And this can actually lead to viruses and bacteria being more likely to infect you, right? Because the immune system's less responsive, but when it suddenly responds, it responds quite badly, and you get a much more severe infection, right? Remember, an infection is the virus getting inside your body, but the symptoms you have, the sneezing, the cough, the temperature, are the immune system trying to kill the virus, not the virus's actual effect on the body. And so if your immune system's overreacting, you're going to have much worse symptoms. Whereas previously, it may have just identified the problem and got rid of it with very few symptoms, right?
I see. Fascinating.
So, during the school year, their immune system's probably clearing the infection pretty easily without any symptoms. When they come into half term or Christmas break, it's more likely that they could have a more severe allergic response, if you will, to the infection that they may have when they see other family members.
Yeah. And one thing I've read of yours is around diet, and I never even thought of diet as an area that would be relevant here, but it is, isn't it? What you eat matters, how you eat it, and presumably when, sometimes as well.
Diet's so important. I mean, your intestine is another immune organ, and it contains about 40 trillion bacterial cells, more cells than there are human cells in your entire body, right?
Okay.
There are about 35 trillion human cells in your body and about 40 trillion bacterial cells in your intestine. So, that's 5 trillion more. But those bacteria digest your food, right? When you eat your food, it goes in and some of it's absorbed as it goes down the intestine, and that helps to feed your body and keep you fit and healthy, right? But the rest of it, when it hits the bacterial community in your colon and your large intestine, they consume that food. And when they do that, they release chemicals, compounds from their, like their poop. That's their chemical poop.
Yeah.
And bacterial chemical poop is actually absorbed by our body and helps to feed our immune system.
Okay.
You can cut that or break it, but
No.
So when bacteria eat your food that you've consumed, they poop out chemicals which feed our immune system. So one of those chemicals is called butyrate, and when bacteria in your intestine produce butyrate, it feeds the immune cells lining the gut and keeps them from being inflamed. Right, so It stops massive bad inflammation, and we think that that's incredibly important in shaping health.
And so, as a school, are there dietary decisions you have to make either for your staff, or, allowing them to eat at certain times, or providing certain foods for staff and pupils to eat in the canteen, or does it not really matter as long as you're following general healthy diet advice? Are you okay, basically?
Yeah, it's unfortunate that in this case, Jamie Oliver might have been accurate in terms of what was needed in school diets. In order to keep your bacteria healthy in your gut, and therefore to keep your immune system healthy and your body healthy, you need to feed them fiber. Okay. Fiber is one of the key things you can do, and that's that can come in fruit, it can come in salads, it can come in less cooked vegetables, but they need that fiber, right? Fiber is super important, and less sugar. It sucks, basically. It's like eating all the sugary foods and the high fat, high sugar foods like your burgers and fries, and eat more healthy foods. It's not rocket science, right? It's probably a lot more complicated than rocket science, but it's super simple. Yeah. If you eat a healthy diet, you'll have a healthy gut and you'll have a healthy immune system. So in school, the best thing we could do for children, especially poor children and lower socioeconomic status who may not have access to healthy food at home, is to feed them a healthy diet. And if we feed them a healthy diet, their immune systems will be healthier, will reduce overall disease and allergic chronic diseases in our population, and make the body healthier. So
we've talked about all these different areas that school can help with. I mean, we're not going to put all this responsibility on schools. Obviously, the home environment's almost certainly more important. But if we're looking at a dirt-friendly school, we're looking at a healthy diet. We're talking probably about moving classrooms, so we're not in the same space, or at least having a well-ventilated classroom. And we're talking about good outdoor space and safeguarding our break times.
Yeah, and I mean, I think all three of those are great, right? The best thing you could do during the spring, summer, and autumn is to open the windows as much as possible and allow outdoor air in, so unprocessed outdoor air, and that will significantly benefit that environment. But as we said, those break times are important, but we can still make them learning break times. The psychology of playing with your friends is incredibly important. A lot of kids don't get that outside of school, but also you can make it a farm break time, right? So even if you're just growing things in pots, get the kids interested and excited in nurturing plants, and just the act of working with a plant and with soil is incredibly important. Not only is your immune system in your skin getting the exposure, but just by being close to soil, you're breathing things in. You're breathing in a lot if you're even interacting with a plant, and that's training the immune system in the child's body to be less responsive. So those kinds of things are so important.
It's talking to you is sort of weirdly comforting, but also incredibly dystopian, because I guess anyone listening and watching this is going to go, oh my God, I'm breathing in stuff the whole time, and become almost too conscious of it. I mean, that's not what you want, obviously, but you do want people to realize the benefits of this, but you don't necessarily want to scare them.
It's funny. Well, about 8 years ago, when we first started doing this kind of exposure science, we finally understood the level of exposure most people were under in a building. Somebody asked me the question, how did I deal with public restrooms, toilets? Go in there, it's gross, right? And I said, actually, we did a large study of public restrooms in a university, and it turns out that the vast majority of what you're being exposed to there isn't that bad for you. It's not that disgusting. I mean, I wouldn't necessarily lick a urinal, but just being in there is actually potentially beneficial for training your immune system, as long as there isn't a pandemic or a major infectious disease that's being spread through urine or feces, right? Yeah. And then it could be more harmful. But it's our phobia of other people, of their mucus excretions, of their excretions generally, is what keeps us phobic of those environments. But we translated that over the last 100 years into bacteria and the dangers of infection, because that was the way most diseases were spread in the 19th century and the early 20th century, before we cleaned up our act, before we realized microbes could be causing it. But nowadays, most toilets in most developed nations are not a source of infection. And so the paranoia about, when you flush the toilet, things, if you don't put the lid down, things flying up in the air and making your toothbrush and making the whole bathroom disgusting, is just paranoia, right? There's virtually nothing in most people's feces which will make you sick or make your toothbrush sick. It just sounds gross.
Early years practitioners celebrating around the country as we speak now, having to do all this stuff.
I mean, it's funny. Look at most babies. Most babies love playing with their poop, and it doesn't make them necessarily sick. And remember, if you're in a family, as long as nobody has an infection that's causing the sickness, it's very unlikely that their feces are going to make you sick. It's just our xenophobia, our fear of the other, right? Our fear of our next door neighbors or our friends and what they may have in their poop. We actually think xenophobia comes from a fear of infection, right?
Okay.
So the fact that when you live in your tribe, and you all interact with everybody in your tribe, you don't worry about their infection because everybody has the same thing because you're all intermingling. And so, you get relaxed. But the tribe from over the hill, they might have a pathogen that might make you sick, and so you stay away from them. Even xenophobia and potentially racism have a microbial origin. I love the concept. And so if we can just make everybody not germophobic, we could cure all the world's problems in the sweep of the hand.
It sounds it. So before you go, you're going to have to tell us what a pediatric oceanographer. Yeah, what does that actually mean?
Pediatric oceanography. I work in microbes in any environment, right? So the oceans, dolphins, oysters, but also in children and childhood development and pediatric diseases. So it doesn't matter where there are microbes. That's what I look at. So it's a term of. It's a term that was applied just because I have appointments in an oceanographic department. But a pediatric oceanographer looks at baby dolphins and baby squid, as well as children. Or we take our children and throw them in the ocean and mix the two up.
And see what happens. And what you're working on now, is there another book in the works?
No, we wrote "Dirt is Good" in response to everybody asking us questions after every lecture we gave. Right, you know, you go and give a public lecture, you get 1,000 questions. So I just write down all the questions and answer them, and so we could just hand out a book rather than having to answer all the questions. We give people a lot more information, but also to counter some of the false information that was being propagated on the internet about many of these things. But yeah, no, we're just continuing to plug away and create new science and push the research boundaries as far as they can go.
Sounds great. Thank you very much.
My pleasure. Have a lovely day.